Alright, so I'm just going to do a little quick test with the voltage drop across the starter. So there's the starter solenoid. There's one end of the contactor, the input. There's the output. There's the wire to energize the solenoid. Right, the chassis is the ground, and this one will be the positive. Right, so we grip in the chassis, nice the ground. I'm using some jumper leads, right? So we wouldn't have the best of connections. And then gripping this one here, the positive, right? And to make sure nothing not shorting out. Right. Then we hooking up the ground to the ground and the positive to the positive. So just to show the connections there, jumper leads, positive on positive, negative on negative. Negative hook up to the chassis or the body of the starter, positive hook up to the input or the input solenoid, right? And if we just touch this here to energize it, it will spin. Right, so I just go in and do the voltage drop test and the current draw. Yeah, so for the current draw, I'm using this meter here, Kaiwitz, or however you pronounce that. Right, I'm clamping it. I'll set it on 600 because it could draw almost more than 100 amps. Press and hold to zero it. Right. So there's that one set up. And I'm using the small fluke here to check the voltage drop. Right, so for the fluke, for the voltage drop, we grip in on the chassis, and then I will grip on the output of the starter solenoid here, so we could check the drop across all them connections and everything. Right, across this connection here, across the connection, this connection there, so we don't know if we have any corrosion. Right, I'm going to put the 2 meters together so we could see the readings. Right, setting this one on the max min so I could get the maximum current draw when I now start. Right, and then we could see the voltage drop. So right now everything on 0, so I was energizing it there. So the max current draw 120 amps, the voltage drop is 8.6. Right, so that means we losing voltage. Right, so we losing voltage drop either in the wires because how they're not connected. So I'm going to do the voltage drop test on the wires now. So again, to do the voltage drop test on the positive side, I'll leave the positive hook up on the output of the starter solenoid, and I'm hooking up the negative to the positive lead, the positive battery pole. Right? And that is because I want to get the voltage drop across the positive wire. So it's reading 12.49, and that is because it's finding ground through the starter coil. So that's why we're getting our voltage. Right? So I go and start it, and we'll see how much the voltage drop really is on the positive side. Right, so we're getting 1.5. Right, so 1.5 volts, 1.51 fluctuating there, right? That's on the positive side. I'm going to do the negative side now. The negative side, I'm just moving this here onto the negative pole, right? And I'm moving this one here onto the body. Right, so we will see the voltage drop on the negative side. So when we energize it, we will see. So right now we gain 0. Right. So we get about 1.3. I think the max was like about 1.8. So when we add the 1.3 from here and the 1.5 from there, we get like 2.8, so close to 3 volts. And now testing with all the load, just testing the voltage drop across the starter. 12.4647, right? So I just touching the positive there, or the negative there, positive there, so that is the voltage. The potential difference across the starter without it energized. Right? But we see that when it was energized, it was about 8 point something volts. Now we see that the positive side have a 1.58 and the negative side have a 1.3 drop.